Hello everyone, welcome to my presentation. Today, I am going to discuss the implementation of a binary classification model for ratings through user reviews. The internet is full of many user-based reviews for a variety of products, whether it be on Amazon or the Apple Store. These reviews, alongside user ratings, contain a vast amount of information regarding user sentiment. My project focused specifically on looking at user reviews of different medications from drugs.com and druglib.com, which had their own associated ratings. One of the most significant issues is for rating systems, as in this scenario or in surveys which contain this form of information, is that people tend to present a biased rating, since there is no standardized scale which constitutes a high rating or what constitutes a low rating. Many studies have found that, especially for numerical rating systems, people tend to give overtly positive scores. That means that even though there may be a significant problem with the product, but it still has some positive benefits, people will still give a high review than what it truly deserves. Especially with online drug reviews, this could potentially mask side effects of the drug, as they are hidden by these positive review scores. The overarching goal of this project was to devise a system to distinguish between the overtly positive scores and the truly positive scores. We planned on using different aspects of each text review to predict the rating. Thus, reviews which were misclassified by the system would be able to identify overtly positive or overtly negative reviews. To do this, I obtained user reviews from drugs.com and druglib.com of users and user ratings for specific drugs which were out of 10. I used the median of score of 8 to divide the reviews by below average and above average. Thus, reviews which were misclassified will tend to look like the other half of data. Thus, they would be incorrectly rated since these reviews was not accurate of their ratings. To build the classification model, I did an 80-20 split of the trained test data. Then I constructed a bag of words model and converted that to a TF-IDF scores. Then used a naive Bayes classifier and a random forest classifier. For the transformer-based architecture, I applied different transformer models such as Electra, BERT, BioBERT, which are all examples of pre-trained models which are available on the Hugging Face database. Then fine-tuned these models with the training set. Overall, I found that Electra outperformed the other models on a variety of metrics. And on here, I have some predicted results of the models. As you can see, the first one is a proper classification, which the model correctly assigned a below average result. As you can see, there's nothing positive about this review. However, the next review is an example of an overtly positive review. The model predicted that it was a negative review, but in reality, it had a score which was classified as above average. Thus, it was misclassified by the model. Looking at the reviews, the user gave a positive review even though there were severe side effects present in the review. Overall, the transformer model were better at providing accurate results than the bag of words TF-IDF score classification. I plan on doing further research into this topic by looking at individual drugs instead of an overarching system of all drugs. So thank you for attending my presentation, and I hope you have a good day.